Good evening, everyone. Myself Anil Kumar, and I will teach you signals and system. This is an important subject not only from the GATE exam point of view, but also to understand other subjects such as control system, where you have to check the stability of the system by applying the different signals, and communication system, where you have to design the different communication system, and in analog electronics as well as in your DSP subject. So this is basically a fundamental subject which does not require any other subject to study prior to it, but other subject definitely needs signals and system, because you can't study communication system and control system, especially before studying the signals and system subject. So we basically study different signal and system in this subject, and different mathematical tool to analyze the system response. That is the basic goal of this subject. So let's take an example. So in this subject, you have one system. Let's take an system, and you will apply some input signal, and you will get some output. So basically, the system will process the input signal. It will process the input signal, and it will produce some output. So in this subject, what we will do, we will do the mathematical modeling of different input signal. So we will convert like sine wave into a sine expression, and unit step signal into a some kind of expression that we will study soon. So we can develop a mathematical model for the whole system. For example, we will convert it into a math expression. Similarly, this system response into a math expression, and the output in terms of a math expression. So as you can see, everything is in a form of a mathematical model, basically. So everything, it is in the form of sorry mathematical expression. So when we do the mathematical analysis, it is very easy, because we can take certain assumption which is practically we generally don't consider. Mathematically, we can consider the ideal situations. Practically, like, which is quite difficult to do. Mathematically, the things are like quite easy when we deal with the ideal system. So so as you can understand, these are the things we are going to study in this subject. So I will write it formally. Basically, signal and you can say system is to be studied to find the output response for the given input and system expression. So basically, uh, you will give some input to a system uh, uh, whose equation you already know, and then you will check the output response, how the system is behaving to that particular input signal. So you will apply different signals to a system, and you will check the output response. It is a stable or unstable, causal or non-causal system. So this is the basically task of the system, and uh, by to do the thing in a very easy way, we will study the different mathematical tools such as, Fourier series, Fourier transform, Laplace transform, jet transform, DFT. These are the different tools we will study in this subject to make our life easy. You will get to know when we start. So let's start with a very basic term, signal. So the simple question is, what is a signal? How can we define a signal? Basically, signal is defined as any quantity having associated information in it. So there must be some information associated in it. So I will write information in it. So the question arises, what is an information? How can we define an information? Basically, information we can define in terms of randomness. More the randomness, more the information. For example, randomness means which is unknown basically. We don't know, we don't have any prior knowledge of that, which is having more randomness. For example, uh, in a very sunny day, suddenly the rain occurs. Then that is like the random thing. So it contains more information. Uh, uh, and other example, uh, if I do a journey by train, all the trains are going by the normal time. There is no information in it. But if suddenly the train becomes late by 10 hours, then there is an information in it, because we don't have any prior knowledge, or it is like randomly occurs. So more the randomness, more the information in it, basically. So on another example you can take is like sun rises from east. So there is no information. It is like a universal truth. So if suddenly the other way went, then there is an information. So I hope you understand the difference. So if you don't understand this definition, like you can also define a signal like basically signal is a function of one or more independent variables. So basically, signal is a function of one or more independent variables. So the question is, what is independent variable? So for example, if I take an audio signal, which is basically having the two axes. One is the time, and another one is the amplitude. So the voice signal will vary like this. Let's take an example. So in this example, this time is an independent variable, because it doesn't depend on anything. So it is an independent variable here. So it is an independent variable, and this amplitude is a dependent variable, because it depends on the time, because it is varying with respect to the time. So it is a dependent variable. So the audio signal contains one independent variable. So it is a function. Audio signal is a function of one independent variable. So there are different type of signal which is having more than one independent variable. So let's discuss that signal. So as you already know, this is like first type of signal, audio signal, which is having one independent variable. Other type of signal, let's take an example of an image signal. So you already have seen the image. It is like a 2D thing, uh, which is having two independent variable, or the spatial variable x-axis and let's say y. So it contains basically the pixels. For example, pixel are the picture elements. So it contains our picture or image is made up of pixels. These are basically the picture element, or you can say it is made from the colors like RGB, red, green, and blue. So, if you have seen a digital image and if you zoom it, you can see the each pixels like when distorted in a distorted form. So, you can go home and try to zoom a picture as much as possible, and you can see small different colors inside the picture. So that is called the basically pixel. So it contains two basically axes, the x-axis and the y-axis. So it is the function of two dependent variables. Similarly, we have signal with three independent variable. For example, we have video signal. Video is nothing but image, different image, and we are varying different image with respect to the time. So image already having the two independent variable, and one is like the time. So you can say video is having the three independent variables. Because what is a video? If you you can see it is a different image you are seeing at the different intervals. So and that makes a video. uh, so it is like it contains basically three independent variables, two spatial as well as one time variable, basically. So there are few characteristics of a signal that you should know. Uh, uh, One is like the bandwidth of the signal. So basically, in order to know the bandwidth of the channel, we should know the bandwidth of the signal. So the bandwidth of the signal is also an important parameter. We will study all this when we study the Fourier transform. Bandwidth of signal is an important parameter basically, and uh, like other parameters such as like randomness, as we already discussed during the definition of the information. So these are the two important property of or characteristic of a signal basically. So there are different operations you can perform on a signal at a very basic level. Uh, I'm not talking about scaling, shifting, reversal, but in general way. What are the operations you can perform on a signal? Let me operation that are performed on the signals. Generally, all the devices will do these operations. Like every device, for example, your mobile phone, your television, etc. For example, first is like enhancing the signal. Enhancing is like, in other words, you can say amplification. Other you can do is like storing the signal. Basically, you are storing a message, but in the background you are storing the signal. For example, you are storing any video file or your audio file, but in the background, what you are doing, yeah, you are storing a signal in a digital format, basically. So other operation you can do is like extracting, like playing that video, stored video, or extracting. Other operation you can do is like filtering, removing some frequency from the signal, or some taking some desired part and removing some undesired things from the signal. You can do. These are the basic operations that basically nowadays every device perform on a signal, and we made our systems to perform these tasks basically. So these are basically the operation. I hope you understand the basic idea why we are studying this. subject, signal and system, and what is the signal, and what are the different operations we can perform on a signal. So now let's see the different types of the signal basically. So next topic is types of signal. So one thing you should remember is like in signal and system, we will study only signal which is like one independent variable. We will not deal with other type of signal like two independent variable or three independent variable. So one independent variable means like you have two variables in general. One is one independent variable, and you must need one dependent variable. So there are two variables. For example, this independent variable is time, and another independent variable is like your odd signal or amplitude. So there are two variables. So based on the combination, how many combinations are possible? So if we see 2 raised to power 2, which is equal to 4. So there are four combinations are possible with one independent and one dependent variable. So we will so that means there are basically four different type of signal we will study. So uh, for a quick summary, I will make a table and then we will study each type of signal in a detail. So for example, one dependent variable is like amplitude, and another variable is time, and then we will define the type of the signal. So, now see, if your amplitude is continuous and your time is also continuous, then we call that type of signal is continuous signal, continuous or analog signal. Another combination we can make is if amplitude is continuous but the time is discrete. Don't worry about this term continuous and discrete. We will discuss each term in detail next after making this table. So uh, this will give you a discrete time signal. And another combination you can now tell very easily. It is a discrete and it is continuous. Then we can say it is a quantized signal. Another type is like this is discrete and this is also discrete. So can you guess the type of the signal? Yeah, sure, it is a digital signal. So these are the four type of signal uh, possible with these two combinations. So now we will discuss each one of them in a detail. So let's first start with the continuous time signal. So basically, what is the meaning of a continuous? Continuous means which does not contain any discontinuity, basically. So we can say a signal uh, which occurs for continuous time or continuous value of time is called the continuous signal. So, for example, if I assume a signal e raised to power minus, let's say 30 into ut. So, if you draw this signal, it will be like this. So, let's say this is equal to xp. So, you can see at t equal to 0, this term will be 1 and xt equal to 1. Then. So you can see for the positive side, this signal is present for every value of time. So there is no gap or no discontinuity between uh, any time interval, or like at any time there is no discontinuity in this signal. So it is a continuous signal basically. Or if you don't understand this point, I will tell you. So for example, if there is a signal which is like this, this signal contains this one discontinuity, two discontinuity, and three discontinuity. It is a discontinuous signal basically. Discontinuous signal. Because at, for example, let's say this is 1, this is 2, and this is 3. At 1, you are not sure what is the value of this time. Let's say here it is 1 and it is 2. This is 0. So you can't tell the at t equal to 1 it is like 0 or 1. At t equal to 2 the value is like 1 or 2. At t equal to 3 the value is like 2 or 0 or any value in between this. So this is like discontinuous signal, or like you can say here in between 2 to 3 it is continuous. Similarly here like 1 to 2 it is continuous, but overall this signal is discontinuous basically, or you can say the piecewise discontinuous signal basically, this type of signal. So I have to understand what is a continuous time signal which available on all the instances of the time. So other type of signal as we already mentioned about is discrete time signal. So basically a signal which is continuous in amplitude but discrete in time, or discrete I mean is like integer. Integer value of time index, because the term discontinuous is like sometimes confusing. So the term we can in simple way we can say is like integer value at the time instance. So that type of signal is called discrete signal, which is having discrete in time but continuous in terms of amplitude. So for example, uh, like if I draw a signal and which take only discrete levels like 1, 2, 3, 4, and so on the time axis, and on the amplitude axis it can take any value. For example, this is like 3.1, this is say 3, this you can say 4, and so on, or 4.2 you can say. So at the amplitude you can see it can take any value, but at the time axis it take only the integer value basically. So that type of signal we basically call discrete time signal. So the question is how we get this type of signal. Basically, uh, we can obtain discrete time signal from the continuous time signal uh, using a technique called sampling. So basically, sampling is a technique by which you can convert your continuous time signal into discrete time signal. And you remember, this is a phenomenon of time axis, not the amplitude axis. This is very important because later we will study quantization, which is a phenomenon of amplitude, not the time. So generally people confusing these two terms. So keep in mind. So how we do sampling? For example, sampler is basically a simple switch. Take a simple switch. Let's say it is a simple switch. This simple switch is we called as a sampler basically, or I will write a simple switch on off. So it take continuous signal. Let's say xt, and for example now you want to turn this switch on and off at a particular interval. So let's say at t equal to nts you want this switch to turn on and off. So what output you will get? You will get output in terms of x and ts. Simply replace that t with the nts basically. So you will get a discrete signal here. So the thing is, what is n and what is ts? So n is nothing but any integer value. You can take any integer value in this, like 0, plus minus 1, plus minus 2, and so on. And ts is basically the sampling time. Like at how much gap we want this switch to turn on and off. This is basically defined by this sampling time. So you can make a note of it, like sampling time for a simple in terms of a very simple definition. The sampling time defines the what gap to provide to sample the signal basically. So later we will study the sampling theorem and all, then you will get a more clear definition of it. So let's try to take one example and try to convert any continuous time signal in a discrete time signal. So we can take the above signal, for example. Let's take the signal we used earlier. Xt is equal to e raised to power minus 3t into ut. So what we want, so you can see we replace t with nts. So this x and ts will be equal to e raised to power minus 3 nts un ts basically. So for the simplicity, let's assume ts is equal to 1 second. So you want sampling time 1 second, which is defined by using the sampling theorem basically. So you are not taking this ts as a random, it is like a sampling theorem you will use. But for the simplicity in the signal system topic, we will assume this. So if ts is 1, then it x and ts will be equal to xn, which is equal to x minus 3n u of n. So this is basically your discrete signal, and this was your continuous signal, continuous time signal. So graphically, how will you understand this things? So let's see. So I will draw both the signal simultaneously. So this is your xt, this was your t. This is now e raised to power minus 3t will look. This value of course will equal to 1. So this you take xn, and this is like n, because you can say this is we are drawing signal with respect to n and then xn. I know these are the small thing, but later people will confuse with these things. So what I will do, yeah. So what I am doing here, I have to sample it. So I am sampling it at a particular value of n, like n equal to 1, n equal to 2, n equal to 3, and you will get different values. So at n equal to 0, you will get value equal to 1. At n equal to 2, this is 1, this is 0, this is 2, this is 3. So at n equal to 1, you will get a value e raised to power minus 3. At 2, you will get e raised to power minus 60, sorry 6, and you can draw a symbol like lollipop. And at 3, you will get it e raised to power minus 9, and so on. So you can do sampling like this, and you will get a sample version of signal uh, like this. So this is a simple procedure. You can convert a continuous time signal into a discrete time signal. And the important thing to note is like Ts, which is equal to we took it here 1 second, but Ts will depend on the sampling theorem. And sampling theorem you will study in communication system as well as in signal system also. So later in the part I will explain how the Ts and Ts will define. So for the simplicity, you can say the sampling theorem tell us uh, sampling theorem. Sampling theorem will tell if a sampling frequency should be greater than or equal to 2 FM, and if you take equal to we need an ideal system, so that's why I consider Fs greater than 2 FM, and this Ts is basically 1 upon Fs. So this is the relation, and based on this relation you have to take the Ts value. So but you can think is all the discrete system made from continuous signal, like by doing the sampling, or is there any way like directly we can't get directly like discrete time signal? So basically every discrete signal is not sampled version of the continuous signal basically. So I will write every discrete time signal is not the sampled version of continuous time signal. So, for example, uh, in a cricket match, in a cricket match, if you plot the things runs versus overs. So you can say in 1 over, player scored 6 runs, and in second over scored like 3 runs, and so on. So you will directly get the discrete time signal. And another example you can take is like measurement of temperature in every 1 hour. So I will write measurement of temperature temp- at every 1 hour. 1 hour or 2 hours based on your requirement. So you will get the discrete time signal directly, basically. So this is the another type of signal we studied discrete time. So so you can see we have covered the two basic type of signal out of this continuous time signal or the analog time signal. So like I wanted to tell why it is called an analog signal. Basically, analog is a term like analogous, which is like meaning is like similar. So that's why we called it as an analog signal, which is similar to similar meaning to continuous signal. Nothing else. It is like a fancy term, analog signal. Continuous signal are also called as analog signal. So now we will study the third type of signal, which is quantized signal. Quantized signal. Basically. So what we will do in this signal, here the time is continuous. We will not touch the time axis, but the amplitude, our target is to make the amplitude discrete. And there is a device called quantizer which do this task. For example, if I draw a signal which is continuous in time but discrete in amplitude, so it will look like this. For example, a signal like this. One, let's see, two, and you can say it is a 5.3, for example. So you can say this value, you can say 1, this value you can say 2. This is our amplitude axis, this is time. So you can see the time axis contains the non-discrete values, but the amplitude must have discrete values. So this type of signal basically we call as a quantized signal. So in generally people think uh, like quantization means doing discretizing both amplitude as well as the time. So it is not true. To convert both time as well as the amplitude, we first convert the continuous time signal into the discrete time signal using the sampling, and then we do the quantization, and then we do the encoding to make a signal in an appropriate form. So basically, fourth type of signal, which is digital signal. So as you can see, uh, in the case of digital signal, both amplitude and the time is discrete in nature. So how can we achieve this? First, we have a continuous signal, continuous time signal. We do sampling, then we do the quantization, then we will get our digital signal. And if you want this digital signal in a binary form, you can do the encoding. You will get binary. So you can store that binary number in your computer. So after sampling, you will get discrete time signal. After quantization, you will get your digital signal basically. So and the advantage of digital signal we already know. Uh, we can store the digital signal. Storing is very easy, and we can process the digital signal very easily when compared to like the analog signal, because our computers basically work on the binary numbers, and uh, as you can see, we have converted that continuous signal into binary numbers, so the processing of the signals are very processing is easy. Earlier, it was not the case. Processing was not easy, but with the latest development in the different latest chips by Qualcomm, it is very easy to process because we have now the nano chips and very fast 5G chips like developed by the Qualcomm and the other companies. So yeah, that was the introduction to the signal system. And next we will study some standard continuous time signal like step signal, impulse signal, ramp signal, triangular signal, cosine, and these are the different continuous time signal we will study. And that's it for this lecture. Thank you.